Pascal Math Contest 2002, Grade 9. Number 1. 15 plus 9 minus 6 over 3 times 2. Numerator is the 9 minus 6, 3. That's the plus 5, 18. Denominator is the 6, is the 3. So the answer is C. Number 2, 50% of 2002 is equal to 50% of. We know of in the percentage and the fraction. We use the multiplication. So 50% of 2002. That's the 50% times 2002. 50%, that's the 1 over 2 times 2002. So that's the 1001. So the answer is E. Number 3. If x plus 2 equals 10, y minus 1 equals 6, then the numerical value of x plus y, we just add the two equations together. So x plus y plus 2 minus 1, that's the 1, equals the 16. And x plus y equal to 50. So number 3, the answer is B. Number 4, the value of 3 squared minus 3 squared equal to 3 squared, that's the 9, minus 3 squared, that's the 6 squared, that's 36. So the answer is A. Number 5, Sophia entered an elevator. The elevator went up 7 floors, then down 6 floors, and finally up 5 floors. If Sophia got out on the 20th floor, then she entered the elevator on floor number. So if she entered on the X floor, and then he went up 7 floor, that means plus 7. And then down 6, that means minus 6. Finally up 5, plus 5. Now got out at the 20th floor. That's our equation. So x equal to 7 minus 6, that's the 1, plus 5, 6. Move to another side, 20 minus 6, that's the 14. So the answer is A. Number 6. In the diagram, the value of x is. In this diagram, two lines with the arrow, that means they are parallel. The two parallel lines, the alternate interior angle, that's to the arc, the angle, they are equal. So top angle of the triangle is x degree 2. And the sum of the interior angles of triangle is 180, equal to 70 plus 50 plus x. So x equals 60 degrees. Therefore, the answer is B. Number 7. If n is 5 over 6 of 240, then 2 over 5 of n is. So n is n equal to, we know of in the fraction and the percentage problem, that means multiplication. So n equals the 5, 6 times the 240. So cancel 6, that's the 40. N equals the 200. The question is 2 over 5. 2 over 5 of still multiple times n 200. Cancel 5, that's the 40. That's equal to the 80. Number 7, the answer is B. Number 8, the value of the 1 minus 5 to the power negative 2 is, so exponent law, a to the negative m equal to 1 over am test point. So this one equal to the 1 minus 1 over 5 square. 5 square, that's the 1 over 25. That's the 24 over 25. So number 8, the answer is A. Number 9, a rectangle is divided into 4 smaller rectangles. The areas of 3 of these rectangles are 6, 15, and 25 as shown. The area of shaded rectangle is, look at the first row. 6 and 15, common factor is the 3. So this width will be the 3. It's the 3 times 5. 6 is the 3 times 2. Now we get the 5. Here is the 5. And here is the 5 too. Now we got the 5 and 2 shaded area. 5 times 2, 10. So the answer of problem 9 is E. Number 10, toothpicks are used to form squares in the pattern shown. 4 toothpicks are used to form a square, 7 to form 2 squares, and so on. If this pattern continues, how many toothpicks will be used to form 10 squares in a row? So the figure 1, that's the 2, that's the 3. So figure 1, the toothpicks is the 4. Figure 2 is the 4 plus the 3. That's the 2 minus 1 times 3, because each time we add the 3. So the first one is the 4. Second one, that's the plus 3. That's the 7. Plus 3, that's the 10. So the third one is the 4 plus, that's the number is the 3 minus 1 times 3. Continue on, we can get the pattern. Now we find the pattern. Nth term equals the first term, that's the 4, plus n minus 1 times common difference 3. So in this problem, how many toothpicks will be used to form 10 squares in a row? So 10 squares, that's the 10th term, that has the 10 square. So equals the 4 plus 10 minus 1 times 3. That's equal to the 4 plus the 9 times 3, that's the 31. So the answer of the 10, that's the C. Number 11, ABCD is a square with AB equals x plus 16, BC equals 3x as shown. The perimeter of ABCD is, because ABCD is a square, so all the side lengths are equal. That means the x plus 16 equals 3x squared. All four sides are equal. So that's the 2x equals 16. X is 8. X is 8, and the side length is the 3x. That's the 24. Or x plus 16. 8 plus 16. Still 24. So perimeter of the ABCD, use the side length, the 24 times 4. That's the 96. So the answer is C. Number 12, in a sequence of numbers, each number except the first equals twice the previous number. If the sum of the second and the third in the list is 24, then the sixth number is. So if the first number is the x, next number will be the 2x and then 4x. This is geometric sequence. Each time the ratio r is the 2. So that's the 2, the sum of 2 is the 2x plus the 4x equals 24. 6x equals 24. X, that's the 4. X is the 4. The geometric sequence, the general term an equals the a times rn minus 1. So the a is the x, so that's the sixth term equals the x times 2 power, that's the sixth term, that's the 6 minus 1. X equals the 4 times 2 to power 5. 2 to the power 5, that's the 32. So the answer is the 128. That's the choice E. Number 13, triangle ABC has vertices ABC. The area of triangle ABC is. Triangle ABC. AC, length of the AC, that's the from here to here. That's the use the y1 minus y2. That's the 2 minus -4. That's the 6. So AC is the 6. The equation of the line AC is the x equals 1. So that's why it's perpendicular to x. And because AC perpendicular to x-axis, so the height here is the height. For this point, that be the x-intercept, so that's the 1 and the 0. Because on the x equals 1 line, all the point x-axis, all the x-axis is 1. So if I label this one at the D, so the BD, that's the height, equal to the 4x2 minus x1, that's the 1, so equal to 3. Area of the triangle is the 1/2. Base, that's the AC. Height is the BD. So that's the 1/2. 6 times 3. Cancel 2. That's the 3 times 3. It's 9. So the answer of the 13 is E. Number 14. A class of 30 students wrote a history test. Of these students, 25 achieved an average of 75%. The other 5 students achieved an average of 40%. The class average on the history test was closest to, we know the average equals sum of the numbers divided by number of the numbers. Also, the sum of the numbers equal to the average times number of numbers. In this problem, they ask the average on history test. So average equals sum of the total students, that's the 30, sum of the 30 students divided by 30. Sum of the 30 students, they given 25 students achieve the average of 75%. We know the of, that means the multiplication. So first the 25 student is the 25 times 75, and the another 5 students achieved 40%. 5 times 40. So that's equal to the 30. So 40 equals the 5 times 8. So we use the 5 times 5, 25 times 75 plus 8. Cancel the 5, that's the 5, that's the 6. So that's equal to 6. 5 times 83. So 5 times 83 divided by 6 is equal to the 69.16 repeating. So they ask closest to the integer. So that is the 69. So the answer is B, 69. Number 15. In the diagram, ABC represents a triangular jogging path. Jack jogs along the path from A to B to F. Jill jogs from A to C to F. Each jogs the same distance. The distance from F to B in meters is. So the ABC is the right triangle. So the AC 120, that's the 3 times 40. 160 is the 4 times 40. So Pythagorean triple, 3, 4, 5. So CB will be the 5 times 40. That's the 200. So BC is the 200. Also, they told us the two jogs the same distance. So from AC to F equal to the AB to F. And for the ACAB, the difference is the 40, 160 minus 120, that's the 40. That means if this is the x, CF will be the x plus the 40 because the length, drag length, AB is greater than the AC, so CF must greater than the CB. Now the x plus the 40 equals BC, we already find it. Use the Pythagorean triple. That's the 200. So 2x equals the 160. X equal to the 80. So that's the answer D. Also, if you don't know Pythagorean triple 3, 4, 5, you still can use the Pythagorean theorem. C squared equals the A squared plus the B squared. So, for the Pythagorean triple 3, 4, 5, all their multiples still the Pythagorean triple, like they all times the 40. That's the 3 times 40, 4 times 40, 5 times 40, still Pythagorean triple. Number 16, when the product 5 cubed times 5 to power 52 is expanded, the units digit is. So that's the 5 cubed times 7 to power 52. 5 cubed, that's the 125. Units digit, that also one's digit, is 5. 7 to power 52, we need to find the pattern. 7 to power 1 is the 7. 7 squared, that's the 49. So one's digit, that's the 9. 7 cube, the one's digit, that's the 3. So 7 times 9. 7 to power 4, 3 times 7, that's the 1. And 7 to power 5, that's the 7. Now they every full number repeating. That means the 7 the power repeating in the 7, 9, 3, 1. Every full number repeating. So now is the 7 to power 52. Every full the digit repeating, we divided by 4. That's the 13. Divisible by 13, that means the remainder is the 0. So we know if the divided by 4, remainder 1, first the number, remainder 2, second the number, remainder 3, the third number, no remainder, divisible or remainder 0, that's the last digit. So 7 to the 52, 52 divisible by 4. So one's digit is the 1. Divisible by 4, that means the remainder is the 0. So that's the one's digit. Now, one's digit, we just times one's digit, use the one's digit times one's digit. So, actually, it's something like the one's digit. We don't need to know the front, just the one's digit. Last digit is the 1. And 1 times 5, one's digit times one's digit. There are some number ending with the 5. That means the answer of the 16 is choice A. Number 17, the number 1000 can be written as the product of two positive integers, neither of which contains zeros. The sum of these two integers is. So 1000 we write as the 1000, that's the 10 cube. 10 cube, we do prime factorization, that's the 2 times 5 cube. So exponent law is the ab to power m equals the am times bm. Now they equal to the 2 cube times 5 cube. So for the 2 cube times 5 cube, they have the combination. Actually, they have the 16 factors total, but neither of which contains 0. So 2 cube is the 8. 5 cube, 125. We cannot times any 2 with the 5, will give us the 0. So 8 times 125 equals the 1000. And then the sum of these two is the 8 plus 125. That's 133. So the answer is C. Number 18. Together, Akira and Jamie weigh 101 kg. Together, Akira and Rabia weigh 91 kilogram. Together, Rabia and Jamie weigh 88 kg. How many kilograms does Akira weigh? So A plus J equal to 101. And also A plus R equal to 91. And R plus J equal to 88. These are system of the equation. We can use the substitution or elimination solve the equation. But this system of equation are symmetric. So easy way we do, we add the all equation together. They gave us 2a plus 2j plus 2r equal to 280. And cancel 2 equation both sides. A plus j plus r equal to 140. Now they ask the a, so if we try to find the a, we already know this equation 3 is the r plus j. If this equation I labeled as the 4, I use the equation 4 minus equation 3 elimination. Gave us a equal to 140 minus 88. That is 52. So the answer of the 18 is D. Number 19. The natural number from 1 to 2100 are entered sequentially in 7 columns, with the first 3 rows as shown. The number 2002 occurs in column M and row N. The value of M plus N is. So there are 7 columns. 7 columns, that means the column 1 divided by 7. So the number in the column 1 divided by 7, that's the remainder 1. Column 2, that's the divided by 7, that's the remainder 2. Same thing, remainder 3, remainder 4, remainder 5, remainder 6, and remainder 0. That means divisible. So they ask number 2002. So divided by 7, that's equal to 286. And also no remainder. That means remainder 0. So remainder 0, this number is on the column 7. In the column 7, so that is the M is the 7. And also the row is the N, that's the 286. That's the 286 row and the column 7. 7 plus 286, that's equal to the 293. So that means the M plus N equal to 293. Therefore, the answer is the D. Number 20. For how many integers value of x is square root 25 minus x squared equal to an integer? 25 square root 25 minus x squared is the integer, and that means the 25 minus x squared must be greater or equal to 0. So we can take the square root of negative number. So 25 minus x squared greater or equal to 0. That means x squared less or equal to the 25. 25 is the 5 square, so x greater or equal to negative 5, because negative number square always positive, less or equal to 5. So the possible integer of the x is the 0, positive negative 1, positive negative 2, positive negative 3, positive negative 4. Also, the last one, positive negative 5. Because they said the square root must be the integer, so that means the 25 minus plug in 0. 0 square, still 25. That's the square root, that's the 5. So 0 works. And we plug in the negative positive 1. That's the 25 minus 1 square is the 1. And 24, not the square number, so 1 not works. And plug in the 2, 25 minus the 2 square, that's the 4, equal to square root 21. It not squared number. And the 3, so square root 25 minus positive negative 3 square, all the 9, they equal to square root 16. That's the 4. So positive negative 3, that works. And the 4, so square root 25 minus 4 square is the 16, equal to the 25 minus 16 equal to 9, that's the 3. It works. And 25 minus 5 square is the 25, that's the square root 0, that's the 0. It also works. So the total number is the 7, 0, positive negative 3, positive negative 4, positive, negative 5, total 7 numbers of the x. So the number 20, the answer is A. Number 21, a rectangular block with dimensions 4 cm, 5 cm, and 6 cm is made up of cubes, each with side length 1 cm. If 1 cm cubes are removed from the larger rectangular block, what is the minimum number of these cubes that must be removed so that resulting solid is itself a cube? Rectangular block is the 4 times, so that's the original, the rectangular block. The side length is the 4, 5, 6, 6, 4, 5. Now we remove small blocks one by one to form the new shape. The new shape is the cube. Cube, all the side lengths must be equal. So 4, 5, 6, the smallest number is 4. So we keep the measurement is the 4, 4, 4. Now we get the cube, that's the 4, 4, 4. That is the possible. Remove the minimum number of the cube. We still can do the 3 by 3 by 3 or the 2 cube, but we want to remove the minimum number of the cubes. So that's the 4 by 4 by 4. So volume of the rectangular prism volume is the length times width times height. In this problem, that's the 6 times 5 times 4, that's the 120. For the new one, the remaining volume, that's the 4 cube, that's the cube volume. That's the 64. How many cubes removed from the figure 1 to figure 2? That's the 120. The just left 64. So difference is the 56. So that means the minimum, the number of cube is the 56. That's the minimum we'll remove. Leave us the 4, the by 4 by 4. So for the 21, the answer is E. Number 22. In a school, 500 students voted on each of 2 issues. Of these students, 375 voted in favor of the first issue, 275 voted in favor of the second, and 40 students voted against both issues. How many students voted in both issues? So the total is the 500. So we use the one diagram to solve this problem. Total is the 500 student. So in favor of the first issue, that's the 375 student. In favor of the second issue is the 275. So the favor of the both, that's the x. So only the favor of the first issue, that's the 375 minus x. And only voted in favor of the 2, that's the 275 minus x. And also the 40 students against both issues. That's the total is the 500. So the equation is the 375 minus x, that's only voted for the first issue, plus the x voted in both, plus only voted in the second 275 minus x. Also, the 40 students against both the issue, the total students, that's the 500. So that means the cancel the x, we have the negative x move to another side, give us the x 190. So that's the voted in favor of the both issue. That's the 190 students. So the number 22, the answer is C. Number 23, the number of ordered pairs AB of integers which satisfy the equation a to power b equals 64. A to power b equal to 64. 64 we can write as the 64 to the power 1. And also we can write as the 64 is the positive 8 and the negative 8 square. So positive negative 8 square, they all equal to the 64. Also, that's the 4 to the cube. So only the positive 4 cube, that's the 64. Negative 4 cube is negative, so negative not the answer. And also, that's the 2 to the power 6. Same thing, positive 2, negative 2 to power 6, all the 64. So that's the total pair. The first one, that's the A is the 64, B is the 1. Second is the positive negative 8 and 2, 4, and B is the 3 and positive negative 2 and 6. Total is the 1, 3, 4, 5, 6. That's the total is 6. That's the answer D. Number 24. In the diagram, ABC is the semicircle with diameter AC, center O, and radius 1. Also, OB is perpendicular to AC. Using AB as a diameter, a second semicircle, AEB, is drawn. The region inside the second semicircle but lies outside the original semicircle is shaded as shown. The area of this shaded region is. Now we connect the OB and OA are all the radius. Radius is the 1. And what's the AB? AB is the second semicircle, the diameter. So use the Pythagorean theorem. 1 square plus 1 square equals the AB square. That's the 2. So AB equal to the square root 2. AB, that's the diameter, so the radius will be the half of the AB, so that's the root 2 over 2. Now we can do the shaded area. Shaded area. So that's the shaded area. Shaded area, that's the outside, the first semicircle. So they equals the semicircle area. That's the 1 over 2 times pi r square. Pi, r is the root 2 over 2 times root 2 over 2 bracket square. That's the semicircle area. Shaded area equals semicircle area minus white part area. So if I label the region as the 1, so minus region 1. What's the region 1 area? Now we use the quarter circle area. Quarter circle is this part. So we use the quarter circle area minus triangle ABO area. We will got the region 1 area. So the quarter circle area, that's the 1/4 of the pi r square. For the first semicircle, radius is the 1, so times 1 square, minus triangle, so minus AOB area. AOB, triangle area, equals the 1/2 base, that's the 1, height is the 1. So that's the total area of the triangle. So in the bracket, that's the region 1 area. We use the semicircle. The blue part is the semicircle area minus region 1 area, give us shaded area. Now they equal to 1 over 2 pi times the 2 over 4 minus the 1 over 4 pi minus 1 over 2. And the first term cancel 2. That's the pi over 4. Open the bracket, minus first, still the pi over 4. Negative, negative, positive, that's the 1 over 2. So cancel the pi over 4, that's the 1 over 2. So the number 24, the answer, the shaded area is the 1 over 2. That's the B. Number 25. A student has 2 open-topped cylindrical containers. The walls of the 2 containers are thin enough so that their width can be ignored. The larger container has a height of 20 cm, a radius of 6 centimeters, and contains water to a depth of 17 cm. The smaller container has a height of 18 cm, a radius of 5 cm, and is empty. The student slowly lowers the smaller container into the larger container as shown in the cross-section of the cylinders in Figure 1. As the smaller container is lowered, the water first overflows out of the larger container, Figure 2, and then eventually pours into the smaller container. When the smaller container is resting on the bottom of the larger container, the depth of the water in the smaller container will be closest to. As the smaller container continues lower down, the they will come the figure 3. That's the situation here. Because the top, the line up, so that means the water right now is all of this one will be the water. The height of the larger cylinder is the 20, smaller is the 18. So under the container, the height is the 2. Smaller cylinder continue lower down. Finally, it's rest on the bottom. Now, what's the water level? Water level will be this part. From the 3 to 4, water will all pour into the pores into the smaller container. Now, the smaller container water level, this part. If we use the A to represent this part, it will same as this A. And from the left side, if this is the B, it's same as the B prime. So A is the A prime. And also the right is the C. So in the figure 2 will be the C prime. So from the here to the top, no water, that's the 2 centimeter. This 2 centimeter water all pours into the smaller the container. Now the volume of the A prime, the equal to the volume of the A in the figure 4. What's the volume of the A prime? So volume equals the pi r square times h. So pi r in the figure 3 radius is the 6. So pi r square times height, that's the 2. In the figure 4, the smaller A volume, that's the pi times the smaller container radius is the 5. So 5 square times height, we don't know. That be the x. That's the height be x. So x equal to, so 6 square times 2, that's the 72. 5 square, that's the 25. That's the 2.88. So the height in the smaller, figure 4, in the smaller container is the 2.88 centimeter. So the answer of the problem 25 is D.